This is the introduction to section 4.6. This is part 2. As you're looking at your notes, I'm on page 2 of your notes in this section, and we're going to look at the other proofs that we have here. And again, we're using the HL theorem here in section 4.6 with congruence in right triangles, the hypotenuse leg theorem. Remember, we have 3 checkpoints, so we need to make sure we're putting in the proofs. We need to show that there's right triangles. We need to show that the hypotenuses are congruent, and we need to show that one of the legs are congruent. Okay. So as you look at this example here from the given, it says here BE bisects AD at point C. It also says that AB is perpendicular to BC and DE is perpendicular to EC, and that AB is congruent to DE. So out of our checklist here, in terms of we need to show right triangle, we need to show the hypotenuse, and we need to show a leg. In this case, we can mark off AB and DE would be considered legs. Check. So we can mark that part off. Now we need to show in our proof that we have the hypotenuse are congruent to each other, and we need to show that we have a right triangle. Okay. Well, as you can see, I've already put in the given here for this problem. Okay. So I've already put in the given that what we have here, and now we look at the picture, and it says BE bisects AD at point C. So in other words, BE, this segment right here, bisects this segment at point C. So it's bisecting this segment right here. So I know that these two segments, if it bisects that segment, are congruent to each other. So I can say that AC is congruent to CD. Excuse me, not CD, we'll go DC. Okay, make sure you have the letters in the right order. AC is congruent to DC, and I can say that reason because of the definition of segment bisector. Okay, so right now, as I look at my checklist now, I can say, okay, those two are, as you look at the right angle, these are opposite of the right angle here. So I know that, there's a right angle right there. I know that those two are the hypotenuse, so I can check off hypotenuse. Now I just need to show that I have right triangles. Okay, so my next step as I'm looking here, it says in the given that that AB and BC are perpendicular and DE and EC are perpendicular. Okay, well, because of that, I can say that in this case, angle B and angle E are right angles. And my reason for that is the definition of perpendicular. Okay, definition of perpendicular. Now, if they're right angles, then in my next statement I can say that the two triangles are right triangles. So I could say triangle ABC and triangle DEC are right triangles. Okay, and the reason I can say that they're right triangles is that we know the definition of a right triangle is that if it is a triangle that has a 90-degree angle, it's a right triangle. Okay, so now I can look at my list of 3. I can mark this. I've got right triangles. Now I've got a hypotenuse and a leg. Now I can say that the triangles are congruent by the HL theorem. So now I can say that triangle ABC is congruent to triangle DEC, and my reason is the HL theorem, hypotenuse leg theorem. Okay, so this is another example of using the HL theorem to prove two triangles congruent. Okay, next one, as we look here at example number 2. Okay, in this one it says CD is congruent to EA. AD is perpendicular bisector of CE. Okay, so it's already got marked CD and EA are congruent. Again, you're looking here at, you need a right triangle, you need hypotenuse, and you need leg. Congruent. Well, so far as you look at your picture here, we know where the right angle is going to be. We can check mark off hypotenuse because AE and CD are the hypotenuse of the right triangle. Now, we don't know for sure that it's a right triangle yet. We're going to have to show that, but we're going to be able to show that in our steps. Okay, so that's our given. So let's talk about AD is the perpendicular bisector of CE. So AD right here bisects CE and it's perpendicular to it. So let's talk about the bisects first. If it bisects CE, then we know that this segment and this segment are congruent. Or we know that CB is congruent to EB by definition of segment bisector. Okay, definition of segment bisector. So, I've marked that. I can check off my leg now. I've got the fact that I've got my leg. Okay. All right. So it says that it's also AD is also perpendicular to CE. Okay. So I know now. I also know that since they're perpendicular, that angle ABE and angle DBC are right angles. And my reason is definition of perpendicular. Okay, I know they're right angles. Well, I know that if they're right angles, now I can say, and I'm going to use my statement here, that triangle CBD and triangle EBA are right triangles. And this is definition of a right triangle. And if I know they're right triangles, now again, as you look at your list, we can check that. We can check this off the list. And now I can say triangle CBD is congruent to triangle EBA by HL theorem. Okay. All right. So that's example number 2. Now, this one's not included in your notes, so you're going to need to write this one down. I'll give you a few minutes here to write this one down as you're looking at this, and then we'll go through it. See if you can figure this proof out on your own as well. Okay, now that you have seen this proof and you've written this proof down, let's take a look at it. I've given you that PS is perpendicular to RQ. I've given you that angle R is congruent to angle Q, and I want you to prove that the two triangles are congruent. Okay. Now, as I look at this, again, we're trying to prove right triangle, hypotenuse, and leg. Now, one easy one is, as you look at this, PS is perpendicular to RQ as you look in the given. Okay. And we can say that since PS is perpendicular to RQ, that we can say angle PSR and angle PSQ are right angles. And we can say that reason for the definition of perpendicular. Okay. Well, if they're right angles, then we know that triangle PSR and triangle PSQ are right triangles by definition of right triangles. Okay? And then now I can go ahead and mark these guys. I know these guys are right angles. Okay, so that gives me my right triangles. Now, I can check this off my list, but I don't have a hypotenuse and I don't have a leg. Well, there's one easy leg here. Okay, in step 4, I can say that PS is congruent to PS by reflexive property. Okay, PS is congruent to PS. So now I've got a leg, but I need the hypotenuse. Those two sides of the hypotenuse, they're opposite the right angles. Now, if you'll notice, they said in the given, again, remember, the given is a hint that angle R is congruent to angle Q. Well, if you look at the big triangle now, the big triangle now is a certain type of triangle. Well, if two base angles are congruent, that means it's an isosceles triangle. Well, if the two base angles are congruent, then the two base sides are congruent as well, which means in step 5, I can say that PR is congruent to PQ by the converse of the isosceles triangle theorem. And now in step 6, I've got hypotenuse, I've got leg, and my triangles are congruent by HL theorem. Okay, so this gives you an example of another one using isosceles triangles. Okay, this concludes section 4.6, part 1. Make sure you finish your part 2. Make sure you finish your WSQ.